Okay, so in this video we're going to be looking at simplifying expressions. Now this is the next step on from the Introduction to Algebra class which we just had in the last video. Now in the last video as well I used an example in real life before I even ever mentioned maths or algebra or anything like that. Now I'm going to do the exact same in this one. Okay, so what I'm going to do is I've created my own cafe. Okay, and the way everything works in my cafe is that the harder you work and the faster you work, the more you get paid. Okay, simple enough. If people are going very, very slow and kind of slacking off, they're not going to get paid as much as the people who are working very hard throughout the whole day. So I'm going to come up with a scenario where we've two people, person 1 and person 2, and both people are going to go to different tables with the same order, and we'll see what happens. Okay, so when person 1 went up to the table first in the cafe, there was someone who ordered a tea. There was another person who ordered a coffee. Then another person ordered a second tea. And 2 more people ordered 2 more coffees. So there's 2 teas in total and 3 coffees. Now, person 2 went up to the same table and took the same order, but they said it was a tea, and then they asked for a coffee, and then another person asked for a tea, and then it was 2 more coffees. Now from seeing that, you can see that these 2 were a lot faster to be taken down than these 2. Way quicker to write these. So this person 2, is going to get paid more than person 1 because this was faster to work out, faster to put through the till, faster to serve the customers. Now because you can see that person 2's technique is a lot faster, we're going to use this method for the next step. Now one day inside the cafe it was extremely busy, and it was so busy that person 2 had to go to every table on the way around the cafe to get the orders. Now how did she do it? What she did was went to a table, asked what they wanted. So the first table wanted just a tea, because there was only one person there. The next table wanted 2 coffees. The next table wanted 3 coffees. On the next table we wanted 4 teas and 2 coffees. On the final table someone wanted 2 teas and 1 coffee. So what we're going to do to make this easier to read and easier to understand for the person receiving the order to make the teas and coffees is use what we call in algebra like terms. Now, like terms is when you gather bits and pieces that are alike, that are the same. Like, there's no point you taking this information and giving it to the person who's receiving the order and saying, right, we need 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 2 is 12, plus 2 is 14, 15. We need 15 tea coffees. That makes absolutely no sense. There's 15 items, but they're not the same. Now to make it a bit easier, what we're going to do is collect like terms. So we're going to collect the letters. Now, just to make it a bit easier to see, we're going to use different colours. So for every T, I'm going to colour it in green. And for every C, we're going to colour it in orange. So there's a T there, there's a T there, and there's a T there. So now, that's the T's covered. How many T's have we got? Well, there's 1 here, there's 4 here, and there's 2 here. So 1 plus 4 plus 2 is 7. So we have 7 T's. Now, go to the coffees. Get the orange marker out and circle all of the coffees. Whatever is left over. Now, I hope you can see it in the camera, we can count the orange circles. So 2 plus 3 is 5, plus 2 is 7, plus 1 is 8. And now 7T plus 8C is a lot easier to give to the person behind the till as opposed to all of this rubbish. This is called collecting like terms. Now, what happens if the orders get a lot more complicated? So people don't just want tea and coffee, they want a little bit extra. So on the first table, we'll say someone wanted 2 teas with sugar. So we'll just write tea with S. The next table wanted 3 coffees. But on the same table, someone wanted 1 coffee with milk. The next table, we wanted to get 2 teas on its own, no sugar. Another table wanted 4 coffees with milk, 2 teas with sugar, and 3 normal coffees. Now, how do we put all these together? Now this is the exact same technique. We could say that this TS, this T, and this TS, they're the same, but they just have sugar of a difference. But if that's the case, then they're not the same. You can't put them together, because if I gave the wrong person the wrong coffee, or wrong tea with sugar, or tea with milk, or coffee with milk, that would cause problems. So we can only put together the combinations that are exactly the same. So in this case, we're going to use green for TS. I'll put that together. We have 4 teas with sugar. The next colour, using orange, we'll see how many coffees we have. There's 1 coffee here. There's 1 coffee here. Now, there is coffee here and here, but they have milk, so they're not the same. They're not like terms. They're very, very similar, but they're not like terms. So we can put them together. So 3 coffees there and 3 coffees there is plus 6 coffees. We have 1 tea, plain tea. Again, it's similar to tea with sugar, but it's not exactly the same, so we can't put it together. And the last one we're going to use is the coffees with milk. 4 coffees with milk plus 1 coffees with milk is 5 coffees with milk. And now that is a simplified expression. I cannot make that any more simple. Cannot combine it in any way. And it's a lot easier to read than all of this. Okay, so now we're going to start doing proper examples. Okay, so what I want to do in this question is to simplify the expression by collecting like terms. So to start with a nice easy one, it's x plus 2y plus 2x plus 3y. Now, what do we do? The first thing I'm going to do is get out my colours to make it a bit easier. I'm going to use red for the x's. I'm going to use green for the y's. So with all the x's, I'm going to put just lines under there, a line under here, and for the green one, there and there. Now, as you can see, I have included the sign in front of each variable. That plus is plus 2x. It has to be included, because if you don't, then how do you know if you're talking about money? Do you owe someone money? Do you not owe someone money? You have to bring the sign. It has to be very, very important. Now what happens here? There's no sign and there's no number. Now if you think about when you're talking about money, you might say I have €1. You don't necessarily say I have €1 every single time. I have one €20 note. I have one €50 note. You would say no, I have a 20. I have a 50. I have a ball or a car. So if there's nothing in front of a symbol, if there's nothing in front of a variable, that's just 1. So we can actually write an imaginary 1 in front. Now, what about the sign? There's no sign, there's no plus, and there's no minus. If there's no plus or no minus, you can assume that it's plus. That's just how it works. If there's no sign, it's a plus. if it's negative, you have to have a negative. We'll deal with one of those in a minute. Okay, so now, what I want to do is collect my like terms. So the first thing I'm going to do, alphabetical order, I'm going to go with the x's. So this is 1x. Okay, so 1x plus 2x. Now they're next to each other. The next step, collect the y's. I have plus 2y here, and I have plus 3y here. So now all of our like terms are next to each other. And the final step, combine or collect the like terms. 1x and 2x is 3x. 2y's and 3y's is 5y's. Collected. Simplified expression, collected like terms. I cannot go any further. Now, what if we take an example where we have letters and numbers, or variables and constants as we like to call them, as follows. So we'll say 3a plus 2b minus a plus 4 minus 2. Now, what is going to happen here? Again, same as we did a while ago, take out your coloured markers and use your colours to highlight or underline the like terms. I'm going to use red this time again for A. So there's 3 A's there. Don't forget that's plus 3A, it's positive. Now this is a minus A, so we have to bring the minus with it. Any more A's? Nope, finished. Take the green. Have we B's? Yep, we do. So there's a plus B there. Oh, sorry, plus 2B. And the last one is our constants. Just numbers, there's no letters. So if you want, you can think of these as money or just objects. There's 4 euros, take away 2 euros. So they can combine together. Now, as we did a while ago, I'm going to use it all in one colour to make it easier. 3a subtract a. So 3a, bring the sign, you have to bring the sign, minus a. This is the only b, plus 2b plus 4 minus 2, plus 4 minus 2. Same again. Collect your like terms. So 3a take away 1a. 3 take away 1 is 2a's. Onto the b's. It's plus 2b. There's nothing else. So that's okay. Leave it as it is. Plus 2b. And now the numbers at the end, or the money as we like to call it, plus 4 take away 2 is plus 2. Done. Now, so one final example. What happens if you have variables or letters that are very similar but they're not actually the same? Okay, so if we use, we'll say 4j plus 3p minus 2jp plus 4p minus jp. Do 2 more. What do we say? Minus 6p plus 3j. Now this one is a lot more complicated. We have 1, 2, 3, 4, 5, 6, 7 terms which we need to collect and put all the similar or like terms together. So again, get out the colours. Red is going to be for J. So 4J. Now we have a J here, but it's with a P. They're very similar, but they're not the same. So we have to skip it. There's no J there. There's a J here again, but it's with a P, so it doesn't count. And this one is J as well. That's all of my J's put together. Green. We'll work with the P's. Minus 3 or plus 3p plus 4p minus 6p. And the last one's then jp and jp, so they go together. Minus 2jp minus jp. So we've got them all coloured together. We will rewrite them in one line. So we'll start with the j's. 4j plus 3j onto the greens plus 3p plus 4p minus 6p minus 2jp, I'm just going to run out of space, minus jp. So on the next line, again, collect like terms, same as what we did earlier. 4j plus 3j is 7j. 3p plus 4p is 7p. Take away 6p is just 1p, so it's plus 1p. Minus 2j minus 2jp minus jp is minus 3jp. A lot of confusion, simplified down to 3 collected terms. Now, as I said in all of my videos, there will be a PDF worksheet attached below. It's a downloadable PDF worksheet. You can work on those questions. There's roughly about 20 questions. There will also be a solutions PDF that you can also download, which will have the answers to the 20 questions that are on the PDF worksheet. With that, you can follow step by step, and if you have any problems, if you have any issues with how to work something out, if this video doesn't help, you can maybe try watch it again, watch it a bit slower at your own pace, might make it a bit easier. Or if you're really stuck, just drop me an email. I'll put the email address down below as well, and I can try and help through the email. Okay?